Okay, so now let's talk a little bit about the notation for our inverse functions, right? Inverse functions are one-to-one, so that means that every value of x is assigned one value of x, and each value of x is assigned one value of y. Passes the vertical and horizontal line tests. If we have a function that does indeed have an inverse function, we say that if y equals f of x, we're going to use the inverse function notation y equals f inverse, f with a little negative one in that raised superscript position of x, f equals f inverse of x. So, let's take an example here just briefly. Let's say that I have a graph of a function that turns out to look like this one right here on the graph. Passes the points negative 2, 0, 0, 1, 1, 2, and 2, 3. Well, as we know, when we were looking at our functions before, we had determined that an inverse function reverses the coordinates of the given function, right? So we know that instead of passing through negative 2, 0, our graph should pass through the point 2, 0, negative 2. Instead of passing through 0, 1, we should have 1, 0. 1, 2, let's do 1. And 2, 3 becomes 3, 2. And so if we were to graph our inverse function right here, and I'm going to use a different color blue here, our function should be the kind of function that passes through these points and passes through these points as well, right here, right? So this is how our function should look as an inverse, right? So we would write if y equals f of x, so our upper function right here, this will be the function y equals f of x. And using our appropriate notation, of course, this graph will be that of y equals f inverse of x. A couple of quick notes about this function. First of all, if a function is an inverse, it turns out that the graphs reflect about the line y equals x. So if we're looking at the graph of a function and its inverse, one brief way of getting an idea of what the graph should look like is this reflection about the line y equals x. Every point that's on one side of the graph is reflected equally with the coordinates points reversed in its inverse. So we can actually look at graphs and determine whether or not they're inverses by looking at whether or not they are symmetric about the line y equals x. So that's just a quick test that we can use. So here's another quick question right here. Let's say that y equals f of x is a one-to-one function, and we find that f of 3 equals negative 5. Well, we should say that this function will have an inverse, first of all, because it's one-to-one. And if we're interested in finding f of negative 5, in fact, we can say that by the inverse notation right here, if f of 3 is equal to negative 5, it will imply that f inverse of negative 5 will equal 3. How do we know that this is the kind of thing that must happen? Well, let's take a look at some of our points on our graph again. Just as an example right here, we know that f of 2 equals 3. And that's one of our coordinate points here on the graph. On the inverse function, f inverse of 2, f inverse of 3 is equal to 2. In other words, the points are reversed, right? So that is what must happen here. How about f of 3, f inverse of 3? Well, we know that if it has a y-intercept at 0, 3, it indicates that f of 0 is equal to 3. That's our function notation. So what does that imply? Well, very simply, that f inverse of 3 must equal 0. There we go. All right, more to come.